The next guy to come up with something with gas laws was Joseph Louis Gay-Lussac. He was a French chemist, and in the early 1800s, he developed a relationship for pressure and temperature, which one I think will make a lot of sense to you. Also, he was the scientist that discovered the element boron, and he was the guy that came up with the relationship that in water that there's two hydrogens for every one oxygen. So kind of important what this guy came up with. But what he did is he came up with this relationship of pressure and temperature. Now, remember, temperature, pressure, volume, number of moles, 4 variables. If you're going to mess with temperature and pressure, you need the volume and the number of moles to be constant. How do you keep the number of moles constant? You keep it in a closed container. How do you keep the volume constant? Have it in a container that cannot expand, like an aerosol can or a spray can, where you can't change the volume. So this is kind of what we're talking about here. So he found that there was a relationship between temperature and pressure, and I'm not going to give you the data table, but I'm going to kind of jump to what he ended up finding, is that he found that for a gas, that if you increase the temperature of a gas in a closed container with a fixed volume, the pressure goes up. Think about it. If you have a gas in a container and you heat it up a lot, you worry about the pressure going so high that you blow the container, right? So it goes up, and vice versa. If you cool a gas down, the pressure of the gas will go down. Well, again, as before, what kind of relationship is this? Well, this is a direct relationship. And remember, Charles' law had V over T is equal to a constant. Well, here is P over T is equal to a constant. So just like before, if you have condition number 1, P1 over T1, number 2, P2 over T2, and they're both equal to the same constant, then P1 over T1 is equal to a constant, which is equal to P2 over T2. And Gay-Lussac's law is P1 over T1 equal to P2 over T2. Same deal as Charles' law. Only thing that's different is that it's pressure instead of volume. Okay. And I'm not going to give you a problem on that because it's the same idea. It's the same mathematical calculation that you have. Now, eventually people started figuring out that if you look at what these guys are all constant to, that Boyle's law is P times V is a constant, Charles V over T is a constant, Gay-Lussac's is P over T over constant. Notice that whenever you have them in a form that they're equal to a constant, that you always have a pressure in the numerator, you always have the volume in the numerator, and you always have the temperature in the denominator. Well, what people started to do was to take these equations and say, look, remember pressure, volume, temperature, number of moles. Can we combine these equations in some way to be able to get something that doesn't have so many things that are unknown? And eventually, long story short, they figured out that P times Z over T is equal to a constant. Now, what's not in here? Moles. So the moles are held constant. But P and V and T can vary. So just like before with the other situations, if you've got condition 1 with a pressure and a volume and a temperature, and condition 2 with a pressure, a volume, and a temperature, and they're both equal to a constant, well then P1 V1 over T1 is equal to B2 V2 over T2. And this allows us to figure out 6 with the 6 variables. You got to know 5 of them, right? So to solve for one of the variables, you just do some simple algebra and you solve for the variable that you need. Here we go. Problem. 2.00 liters of gas collected at 25 degrees Celsius, 745.0 millimeters of mercury. What is the volume at 0 degrees Celsius and 760? So the first thing that I can see when I look at this is, I got temperature in Celsius. I got to change them to Kelvin. So when I do that, I get these temperatures. I put in parentheses. I always like to put these guys as P1 and V1 and T1. I always like to put it out and see it so I see what I'm missing and what I have to get. So I have everything except for V2. P1 V1 over T1 equal to P2 V2 over T2. I solve for V2. I get this. So spend time and look at that algebra and make sure you're okay with that. Plug it in, right? But my P1, my V1, my T2, my T1 and P2, notice what cancels. Millimeters of mercury cancels. Kelvin cancels, leaves me with liters. Do the math, and I get 1.80 liters. And that's the combined gas law. I prefer the combined gas law. Whenever anything is constant, I just cancel it out and I'm left with an easier formula. Or you can just always use the combined gas law.